Okay, this lesson is on verifying trig identities, and basically if they use the words verify, prove, or show, they are wanting you to show your steps. That's the big thing. Show your steps. Don't just jump to an answer, but you want to see those steps one at a time. It's kind of like the proofs that you did when you were doing geometry stuff. It's the work that's what's important. And when you do these, you only want to work on one side, which I usually say look for the ugliest side because it'll give you the most options to do substitution with. So work on one side and you'll see what I'm talking about with our examples. But again, if they say verify, prove, or show, show your work. Okay, with example 1, I have this identity that says secant squared theta minus 1 over secant squared is equal to sine squared. So it's kind of like giving us this problem and then saying you should get an answer that is sine squared. Obviously this left side is the ugly side, and that's the one that we're going to work with. So just like we were doing in our previous lesson, we want to look for something that we can substitute. And immediately I see that I can break this apart because the denominator does not have a plus or a minus in it. I can break it apart into two fractions, or I can turn the top into, I believe, tangent squared. So you have either one of those options. I'm going to do the break apart option just because I think most of you aren't quite as familiar with it. But again, I could turn the top into tangent squared and work with it from there. The break apart method, breaking it apart, I can use, again, because the denominator only has one thing in it. It's not added or subtracted. So I can look at this as secant squared theta over secant squared theta minus 1 over secant squared theta. It's like undoing what you normally do when you get a common denominator. You normally get a common denominator and then put the things together. Well, here I'm just backing that apart. So here, secant squared over secant squared is 1. 1 over secant squared I can turn into cosine squared. And then 1 minus cosine squared is a manipulation of that Pythagorean identity sine squared plus cosine squared is 1. So this is actually equal to sine squared, as it should be. That's what they told us. Your last step should always match what it's supposed to be equal to. Okay, if you had chosen to go about working with the left side using replacing the top with tangent squared, then you would have turned the tangent squared into sine squared over cosine squared and the secant squared into 1 over cosine squared, and then flipped and multiplied, and you would still end up with sine squared. So you may have two different ways of getting there. Just pick one and go with it. You may do this, the person beside you may do this, but as long as the steps are correct, then you both get credit. Okay, in example 2, I have 1 over sine minus x plus 1 over sine, or 1 plus sine x. It should equal 2 secant squared x. And obviously the left side again is the ugly side. There's more that I can do with it to get it to look like this right side. Obviously these don't match any of our identities immediately, so I want to do something with them. In this case, I'm going to get a common denominator. And that common denominator would be 1 minus sine and 1 plus sine. And so I write it for both fractions, and then I look at the top. The top had an imaginary 1, or a 1 that now you don't have to write it. You can leave it as imaginary. The bottom of the first one went from being just 1 minus sine to having the 1 plus sine. So I need to put that on top. And then the second one, again, I have the 1 that I can write down or not. The denominator of the second one went from being 1 plus sine to being 1 plus sine and 1 minus sine, so I need to put a 1 minus sine on top. And again, I'm only working on this left side. I want to combine over one common denominator. When I do that, on top, I don't have to really think about distributing those 1s through, so I can just combine. I have 1 plus 1, which would be 2. and this positive sign, and then over here this negative sign, those are going to end up canceling each other out. So I really just have 2 over the common denominator. And now I want to multiply that common denominator out. So I'm going to FOIL. 1 times 1 is 1. 1 times a positive sign is a positive sign. Negative sign times 1. And negative sign times positive sign. And again, I'm always looking for things to cancel. And in this case, the 2 in the middle will cancel each other, and I have 1 minus sine squared. And that I do recognize again as a manipulation of the identity, Pythagorean identity, sine squared plus cosine squared equals 1. If I manipulate it so that I get 1 minus sine squared, that is equal to cosine squared, so I can replace that with cosine squared. And then I can treat, I'm out of room, so imagine if I could pull that over. I can treat this 2 over cosine squared as being 2 secant squared because the cosine is on the bottom. It's like having 1 over cosine. So this is really the same as 2 secant squared. And that's what I was going for, so just put that on your paper underneath this other one. It should look exactly like what our problem was asking us to look like on that right side. Okay, example 3, I have tangent squared plus 1 and cosine squared minus 1 should equal negative tangent squared. And again, I'm going to work on the left side because it has more for me to do. Sometimes it is backwards and you can work on the right. Just happens to be that these examples have all been on the left. Tangent squared plus 1, I immediately recognize it's a perfect Pythagorean identity, so that becomes secant squared. Cosine squared minus 1 is a manipulation of Pythagorean identity, so that should equal a negative sine squared. You got to get that negative in, so make sure that you do your scratch work on the Pythagorean identity to make sure that you have not messed up a sign. At this point, I want to turn things into sine and cosine. This is already sine, so I can come over here, turn secant squared into 1 over cosine squared. And again, I want to think of that negative sine squared as being over 1 so that I multiply correctly. And I can just go straight across and say that I have negative sine squared over cosine squared. And then since sine over cosine is tangent and these are both squared, I can say that this is negative tangent squared. And that was my goal. Now my left side ends up looking like my right side. Okay, this is example 4. We have tangent plus cotangent equals secant times cosecant. And this one, when you first look at it, it's really hard to figure out where to go because you don't see any identities, Pythagorean identities in there. That means you're going to have to use your reciprocal identities. And you can start on the right or the left, but I think I'm going to start on the left just because I can usually, with a plus, put things together. It's harder to separate them sometimes in our minds. So we would have to separate on the right, but I can put things together on the left. So I'm going to turn things into sine and cosine, which is one of my techniques. So I'm going to turn tangent into sine over cosine, and cotangent into cosine over sine. And then I'm in a common denominator situation. And so my common denominator would be sine times cosine. And so once I've decided that, I realize I would need to multiply the first one by sine. That would put 2 sines on top, which would be sine squared. The second one, you went from just a sine to a sine and a cosine, so that would put another cosine on top and make that cosine squared. And then we'll write it as 1 fraction. And at that point, you should immediately see the top is one of your Pythagorean identities. Sine squared plus cosine squared is 1. And then here's where it's kind of weird to think about. You can think about that as being 1 over sine and 1 over cosine multiplied together. And 1 over sine is cosecant. and 1 over cosine is secant. And even though they're reversed, that is what you have on the right because multiplication is commutative. Okay, example 5 is one of the easiest ones you'll find. This left side should remind you of those basic identities where we just turned everything into fractions and a lot of stuff cancels. And we'll do that again. We'll treat sine as being sine over 1, secant as being 1 over cosine, and cotangent as being cosine over sine. And when I do that, my sines are diagonal from each other, so they can cancel. My cosines are diagonal from each other, so they cancel, and I'm just left with 1, which is what I was supposed to get. Okay, example 6 is also very easy. It doesn't look like it to begin with, but if you start by turning things into sine and cosine, 1 over secant squared is cosine squared, and 1 over cosecant squared is sine squared. And then that's one of your Pythagorean identities. So cosine squared plus sine squared is 1. And the left side is now matching the right side. Okay, for our last example, again, both sides are kind of messy looking. And normally I would start on the left. I'm going to start on the right just to show you that you can work these things on the right as well. It's just a lot of them have ended up on the left. And so what I would do on the right is it looks similar on the bottom to one of the Pythagorean identities, except it's not squared. So what's going to happen is I'm going to multiply by the conjugate of that, just like we use conjugates with radicals, we're going to use them here. So instead of 1 minus sine, I'm going to multiply by 1 plus sine. And on top, I'm going to leave that. I'm not going to multiply it out. I'm just going to leave it as cosine and then a parentheses 1 plus sine. But I am going to multiply out on the bottom. 1 times 1 is 1. 1 times sine is sine. Negative sine times 1 is negative sine. And negative sine times sine is negative sine squared. And then that allows me to cancel the two middle. And again, I have not messed with the top, but I have 1 minus sine squared on the bottom. 1 minus sine squared is part of Pythagorean identity that's just been rearranged. So again, keep the top and replace this denominator with cosine squared, because 1 minus sine squared is the same thing as cosine squared. And then immediately I see that I have this cosine on top, which I've lost an x somewhere, sorry. I have this cosine on top that will cancel with one of these, because it's like having 1 on top and 2 on the bottom. So I'm going to cancel this one with one of those, and I will have 1 plus sine over cosine. And at this point you may be like, well, that's just almost upside down what we started with. It is, but it's actually better for us to work with because now that the denominator is one piece, I can separate this like I separated that first example. So I'm going to say that is 1 over cosine plus sine over cosine. And 1 over cosine is secant, and sine over cosine is tangent, and that's what I was going for. We actually match now the right side and the left side. So again, you can work on the right or the left. If you're trying these and you get stuck on the right, try the left and see what happens. Okay, that concludes this lesson.